Welcome to Grasshopper for Rhino, ABCs, 1, 2, 3s. This is the last video on maths. There are some interesting scripts in here. As you can see what I've done, I've taken all the nodes in the purple categories for what maths contain, and then I've gone ahead and put scripts to almost every single one of them. I hope you find that interesting, and we're going to delve into it and see what happens. This is the section we're going to actually do. My color's off the page of my other monitor. I'll try and get over there without messing it up. And that's the section we're going to do. So let's jump right into it. Here we go. I'll bring my face over here. What we've got is I want you to start thinking about this final section on utilities and how that can be helpful or not to changing geometry. So I'm going to give you a few tools. You may not have ever thought about how minuscule epsilon is. Don't even start to fathom what it could do. You have to think real small when you're thinking epsilon. Anyway, you can jump into the factoring up certainly the golden ratio at 1.6. You can factor up the natural logarithm from 2.7, yada, 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 and pi at 3.14, yada, yada, yada. I use that a lot. I use that a little. I use that slowly, and I've never used epsilon. Just haven't had any reason to bring it into my Rhino document as of yet. Maybe I'll have to get into it if I get into other data or from other sources and have to deal with downsizing things. The next section I want to show you is pretty basic. It's your minimums and maximums. There's 3 in a list here. I brought them in ABC, AB, and AB, and that's exactly what it's doing, finding the extremes, the high and the low of those numbers. So if I bring this one up, obviously 8 becomes the low. If I bring this one down, 12 becomes the high. Everything's adjusted according to that. And those number sliders can find your min-max and then separately your min and max. I also want to go into the rounding, which is pretty wonderful. You can take a number, you can round it, and it'll just take whichever one's nearest, but otherwise you can specify if you want it to go to floor or ceiling. You're definitely seeing evidence of floor or ceiling. Let me drag this over here. The merge is what I'm using on this data, and I'm bringing it into an average, which is exactly that. If I change these numbers, I change the average of those numbers. I like my setting 1, 2, 12, and 122 as an example. I take the same data and I bring it into blurred numbers, which is pretty awesome because you can actually blur those numbers by this strength, and that changes your series of what you're looking at in those four numbers. You also have a sense of iterations of how often you want to do that, so you can start playing on some pretty cool numbers as well. You have a Boolean toggle that locks the fact that the first and last value change or don't change. So if I put it to true, it's going to lock those values at 1 and 122. And then I can wrap it also. So I can do true to wrap it, and that's going to influence that, probably override the lock. Here we go. We're going to then take a look at interpolate data. So you take it, and that's exactly what it does. It interpolates a collection of data. So if I bring in all 4 of those numbers, 1, 2, 12, and 122, it will, by this parameter, move throughout that from 1 to 122 and anywhere in between. It's like a points on curve, but it's kind of cool how you can play it. Think of the parameter between 1 and 0, or 0 and 1. This is a very cool tool, the blurred numbers and smooth numbers, because what it does is as you affect the numbers. So watch this 122 as I change this 122. It's got a delay. And that can be pretty incredible for experiencing simulations, not just as animations, but actually think of your geometry as you want to see it transform right in front of your eyes. It's got that slow pace. So I think that's pretty darn incredible. And judging on the size of the number slider, this one's an integer, so it doesn't have much patience. That one's got that little delay, but it does send it over to, actually, I didn't watch it, so take a look. As we move from 2, it's pretty cool. Go to 2, it's going to take some time to get down there as a float. Same way with 1. It's going to take some time to jump down to 0. So it's kind of smart and wise on where the number slider's at. Pretty cool. Have not used it. I definitely am going to. Truncate is pretty cool. It just takes data how far out from the center. So if you started at 0, if you see this running its steps in this range from, well, I'd have to gather that and see what it actually is, the full range of it. I did put a param viewer over here, so I see I have 404 pieces of data. Well, as I do that, I can decide how much of a truncated factor I want until I truncate it right down to not existing. So I can truncate that anywhere between the steps, the input factor of that range. And then I've also had to flatten that data. And if you don't know what I've done there, if I don't flatten the data, I believe I get different types of outcomes here. It's a little difficult to see. It still truncates, but it does a different thing. So I understand that more when I flatten the data and look at it as a list of all these numbers. And what I can do is, I haven't done this yet, but since we're getting in the sets, I'm going to jump over and grab a list length item and find out how long that list is and just grab myself a little bit of a param. Should get in the habit of working off of this, memorizing icons. So you got 124 in that list to start. As I play off of this, I can have a different amount of numbers, and of course I can truncate it differently. Now start thinking about how that information actually manipulate your geometry as you start to apply it. We are going hard into sets, which I think is stage 2 of math sets and vectors, and we're going to do our best to get it done. But you can see how much that grew, and I actually only pulled out one real function that I think is worth bringing into anything to show other people, which was this one, the first cool GH file worth playing with. So all that work, along with going through all the params. This is Grasshopper for Rhino Maths, Wickerson Studios. Check out my YouTube station, Michael Wickerson, and subscribe today. Starting to pick some people up, starting to get some interesting questions. I am there for the beginner in this series, even though I like to go a lot deeper. I've been playing with Grasshopper for a little over a year, and I think my mind, at least in construction and making, allows me to go into it, being a sculptor for over 2 decades. And you'll see some interesting scripts, but they will depend on these maths, and I'm going to do the best job I can to work from math sets and vectors before I start working on any solids in any way, shape, or form. I want my files to move fast. I want them to hustle, and you can always do that by going to display and checking out your Canvas widgets. And when you start doing your profiler, it will tell you a percentage, or it will tell you milliseconds to seconds of how long it takes a node to run within a script. Thanks very much for watching. I'm so happy I'm done the maths. I'm going to use them like crazy as we get into sets, and things are going to abstract through lists, sequences, sets, text, and tree information. Is going to slow us right down because I got to get into relative and relative items. And Mode Lab's advanced algorithms and intermediate algorithms will allow a few examples for me to pull out. I'm not going to try and do anything live because the potential for error in me doing it is pretty high, and I don't want to waste your time. Let's keep these videos under 10 minutes. I was hoping to keep them under 5. Thanks for